The world's first hydrogen combustion outboard motor is here. Yamaha is looking into all kinds of different technologies, whether that's battery electric, fuel cell, sustainable fuels, or even hydrogen combustion. When you think of Yamaha, your mind probably jumps to motorcycles, pianos, or maybe those zippy little watercraft that bounce across waves. But here's something you might not know. Yamaha has been quietly revolutionizing engine technology in ways that reach far beyond their own product lines. Here is the Yamaha prototype. It's basically looking like an X-Tow pretty much. I mean, here is your deal, hydrogen engine. Their latest innovations aren't just improving performance or fuel efficiency by a few percentage points. We're talking about fundamental changes to how engines work, changes that have caught the attention of engineers and manufacturers across multiple industries. The hydrogen revolution. Yamaha shocked the automotive and marine industries when they successfully developed a hydrogen-powered V8 engine based on Toyota's existing gasoline architecture. This wasn't just a concept gathering dust in a research facility. In 2023, Yamaha demonstrated a working 5.0L V8 that runs on hydrogen fuel, producing around 450 horsepower while emitting nothing but water vapor from its exhaust. What makes this achievement remarkable is the approach. Instead of designing an entirely new engine from scratch, Yamaha modified an existing internal combustion platform. They kept the basic structure of Toyota's naturally aspirated V8 but reimagined the fuel injection system, cylinder heads, and combustion chamber designed to handle hydrogen's unique properties. Hydrogen burns much faster than gasoline and requires different air-fuel ratios, so the engineering challenge was substantial. The industry impact has been immediate. While electric vehicles dominate headlines, hydrogen combustion engines offer something batteries can't: the familiar sound, feel, and character of traditional engines without the carbon emissions. For enthusiasts who love the roar of a V8 or the scream of a high-revving motor, this technology represents a potential future where performance and environmental responsibility aren't mutually exclusive. Racing teams have taken notice too. Hydrogen combustion could allow motorsports to continue with minimal rule changes while drastically reducing their environmental footprint. The engine can be refueled quickly, unlike battery electric vehicles that require lengthy charging stops, and it doesn't carry the weight penalty of large battery packs. The Crossplane crankshaft innovation. Step back a bit to 2009 and you'll find another Yamaha innovation that fundamentally changed motorcycle engineering. The Crossplane crankshaft in their YZF Roan Superbike wasn't just a minor tweak, it was a complete rethinking of how four-cylinder motorcycle engines deliver power. Traditional inline four engines use a flat plane crankshaft where pistons move in pairs, creating a smooth but somewhat predictable power delivery. Yamaha's crossplane design staggers the piston firing order unevenly at 270-degree intervals instead of the conventional 180 degrees. This creates an irregular firing sequence that sounds more like a V8 than a typical four-cylinder. But the real genius isn't in the sound. The irregular firing order provides better traction control at the rear wheel. When power pulses hit the tire more irregularly, riders get improved feedback about grip levels, especially when leaning into corners at high speeds. Professional racers immediately recognized the advantage. The engine could produce the same horsepower as competitors while giving riders more confidence in how that power connected to the pavement. Other manufacturers scrambled to develop their own irregular firing order engines. Within a few years, Crossplane and similar technologies appeared across different brands and racing classes. Yamaha had effectively created a new standard in high-performance motorcycle design. Marine outboard technology. Yamaha's marine division has pushed boundaries that ripple through the entire boating industry. Their development of four-stroke outboard motors in the 1990s and 2000s helped phase out the older, more polluting two-stroke designs that dominated for decades. The latest generation of Yamaha outboards includes the X2 Offshore series, a 546L V8 4-stroke that produces up to 425 horsepower. These engines feature direct injection technology borrowed from automotive applications but adapted for the harsh marine environment. Saltwater corrosion, constant vibration, and extreme load variations make marine engines exponentially more challenging to design than their land-based cousins.
Take their MWC series of compact multi-purpose engines. These single-cylinder units displace just 50 to 100 cubic centimeters, but achieve remarkable fuel efficiency and power density through careful attention to combustion chamber, design, and electronic fuel injection calibration. They're found in everything from portable generators to robotic applications. The technology has trickled into unexpected places. Industrial equipment, manufacturers, agricultural machinery companies, and even military contractors have adopted design principles that Yamaha pioneered in these small engines. When you need reliable power in a package that weighs just a few kilograms, every engineering decision matters. Yamaha also developed some of the earliest practical small-engine hybrid systems, combining gasoline engines with electric motors and battery packs in applications where pure electric power wasn't feasible due to range or weight constraints. These systems appeared in prototype vehicles and industrial equipment years before hybrid technology became mainstream in consumer products. Electric motor development. While Yamaha built its reputation on combustion engines, their recent electric motor development shows they're not stuck in the past. Their high-performance electric motors for motorcycles and marine applications demonstrate expertise in a completely different domain. The electric outboard motors Yamaha introduced featured direct drive systems that eliminate gearboxes, reducing complexity and maintenance requirements. The motors are sealed units designed to be submerged, with sophisticated cooling systems that use the surrounding water to dissipate heat from the motor windings and electronic controllers. For motorcycles, Yamaha has developed prototype electric powertrains that prioritize the riding experience rather than just efficiency numbers. They've experimented with artificial sound generation systems that provide auditory feedback to riders, helping them judge speed and power delivery without relying solely on visual displays. This work matters because it shows how a traditional engine manufacturer can transition expertise into electric technology. The precision manufacturing, quality control processes, and engineering culture that produce world-class combustion engines translate surprisingly well to electric motors. Other manufacturers facing similar transitions have studied Yamaha's approach carefully. The ripple effects. The ripple effects of Yamaha's engine innovations extend far beyond their own factories. When a company with their engineering credibility develops new technology and proves it works in real-world conditions, it changes what the entire industry considers possible. Competitors don't just copy the technology, they're forced to innovate in response, pushing the boundaries even further. That hydrogen V8 isn't just an interesting prototype. It represents a viable path forward for combustion engines in an increasingly electrified world, and that possibility is reshaping how engineers and executives think about the future of transportation and power generation.